Trying to change. Yeah, I see why it's cut off.
Yeah.
Change the size.
Yeah, that's sure.
Okay. All yours.
And geez, can you open the G's page?
Which one? Just open it in this one.
Oh, virtually.
No, because so I can switch. Is
Oh.
what?
Okay, that's fine.
Yeah.
Uh,
Right.
oh, you have a by default open a new tab.
Mhm.
Nice.
Sure. It's all,
Right.
I'm gonna,
It's a few minutes.
yeah.
All right.
All right, everyone, we'll get started. I think we are past like 5:38, but yeah, let's get started. A few announcements before we uh, get into intro to APIs. How many of you want to participate in Google Summer of Code? Okay, a few of you. So we'll definitely go do a session and go over like what it is and like how you can prepare yourself and everything. It's not that much actually. But and we are planning to host a intro to open source session. But GSOC, the Google Summer of Code, has opened its applications and it's only till end of March, I think. So please fill it out and go through the list of contributor projects and see which ones you like and submit a proposal for each of them. And this will ensure that you'll have a spot in the summer to like work with that organization or that code base. And yeah, so we'll go through it at a later session, probably next week or something like that. But in the meanwhile, please fill out the application and be prepared and enrolled in the official program. But yeah, with that, let's get started with today's session, which is Intro to APIs or REST APIs. It will be led by our one and only Pavel. And yeah, so I'll hand it to it.
Okay. Hi, everyone. Let's get everyone seated and then we can start. So we have a pretty small session today, just testing out the new location. I hope you guys like it. Just we're gonna be recording this. We're probably going to get quality reporting out of this, so this is going to be on YouTube, so you can, catch up later. We're going to publish all of the slides. This is not going to be as interactive as other workshops, but I will provide some material that we can play around with. So we're going to be talking about APIs today, particularly REST APIs. We're going to explore some of the public ones, and we're going to inspect some of the calls from the web pages and just see how stuff works internally on how, you can call any source of information from any website, and we can inspect that. So it kind of changes your perspective on how the web works. And then we'll talk a little bit about how you can use APIs in your projects, how you can boost your portfolio with that, and all of the good stuff you can make with them. So the first question for me to understand your guys' understanding of the topic, how many of you have worked with APIs? How many of you know what it is, how to call it? So, HTTPS methods, post, get, all of this stuff, right? So if you're not acquainted with it, that's fine. If you are acquainted with it, it's also completely fine, because we all use them, but we don't know actually how they work sometimes, or we don't know some tips and tricks about them. So this could be a good refresher for you. And we're also going to be going through some fun stuff today, so you shouldn't be missing out on anything if you don't know it, and you shouldn't be missing out if you know everything and you just want to see what's happening. So let's talk API first for everybody who doesn't know what it is, for everybody who already knows. It's an application programming interface. So essentially, what it does is connects to services, so like the client and the server itself, and establishes a communication where they can talk to each other, right? Because your client can be a computer, it can be a phone, it can be a toaster that can run Doom, whatever it is, right? But it's a client, right? It's whatever is the user-facing thing. Like I can make this water bottle have Raspberry Pi in it and do some cool stuff. It's a client, right? But then there's a server, which is, your database, your Firebase, or, I don't know, MySQL, whatever you want to use for that, right? And that's your backend logic, where you have your stored users, some data, whatever you want. Or it's not even your database. Maybe it's some other database that, for example, from NASA or from Spotify, from Amazon, whoever else, and we want to connect them, right? We want to use that data in our water bottle or whatever our project is. So that's how we make sure that they can communicate. Easy protocol language that, both of them understand. So that is defined by developers, and that helps you communicate. Now, the best example that I've ever seen was from, I think, Postman. It's that the backend is your kitchen in the restaurant. The API is your server or waiter, and the client is the person who came into the restaurant to order some food. So the menu is basically your documentation where you see all of the possible APIs, how you can call them, what you can get from them. Then you order it from the waiter, and the waiter goes to the backend kitchen and gets the actual food back to you. So that's really nice, because you don't know what's happening in the kitchen, you don't want to know, you just want the food, and you know how to read the menu. That's all you need, that the menu is understandable for you. So the client sends a request, which is the restaurant menu, whatever the option is there, and the API returns the response, which is the meal from the kitchen. So there are a couple of architectures, just to quickly touch up on this. There is REST API, so representational state transfer. It's the most popular one for web applications and mobile applications. So if you want to build a project with them, or you've already used them, you probably use that type. So it supports JSON mostly for data transfer, and it's basically easy and very plug-and-play solution that will help you to build anything that is user-facing. SOAP is an interesting protocol. It uses XML. It's pretty hard to read. Usually you see that, and you want to know that for big corporate companies that have some internal stuff going on, they like to use that still for some reason. It's easy to communicate with the service, because if you are running a big corp, you probably have a lot of XML stuff already, so it doesn't hurt. But I would say for your personal project, let's just keep it REST, because SOAP is similar. If you know REST, you know SOAP too. There is also GraphQL, webhooks and sockets, and gRPC, and all of the other kind of stuff that can be called APIs. Now it's like a broad term, it's like, what do we call computer? If I attach Raspberry Pi to this, is this a computer? Technically, yes. Also, no. What are the components? All of that stuff. So like you can define it properly, but essentially it's something that returns your data when you ask for it. So yeah, REST is the most popular one. It uses HTTP requests, so we all know them. This is what you type in the browser, and it opens the web page. This is HTTP request. And they're also called RESTful APIs, so REST, RESTful, same thing. And we'll be going through them a lot today, so I'll just show you around some cool stuff. So the API client is what we talked about. This is you, the user, who is ordering something at the restaurant. And this is a very good example of the Google app. So Google app uses APIs, and a lot of them, to give you anything. So for example, you search, you press the button to search, it calls an API as a clear, right? You open that little button with the E on it, which is your account, and it opens your account where you can log in. And you know that the login page and the search is the same on web, on your TV, on your mobile phone, everywhere. It's the same. Why? Because they use APIs, because APIs can unite the toaster and the computer and the supercomputer and whatever you want to run it on, which is great, right? So Google Search is a very good example of RESTful APIs that just exist there and you just interact them with every single day. So they are triggered on user actions usually, right? So it's a button click, search, open page, something like that. There also can be some other cases where it's webhooks, so something happens and then it calls your backend, some external thing, not the user. So for example, payment processing, right? You bought a subscription, calls your backend to tell you now this user has a subscription. That's a webhook when you listen as a backend to something, right? There's also sockets. That's what they use in, for example, chat applications, where you're just connected to the same server and you emit stuff back and forth, so you don't have to actually call for it. You just listen to it. Because if you're, I don't want to overwhelm you with all this stuff if you're new to this. If you're not, then you already know this. But essentially, the key aspect to know with REST APIs is that they are not the ones that we listen to, right? We call them once and they give us a result. We can't get live data from them. It's a misconception, right? So HTTPS offers, the put, get, delete, post stuff. Everything else, for example, to, I don't know, track live stocks or something like that, right? You can't do it. What you can do is call the API every 0.05 seconds, which is the same route, and then we'll return some data to you. But that's not very efficient, and there are better solutions for that, so we'll just say that it can do that. But essentially, yes, you send a request, you get a response. It's a one-time thing, just you get it, you forget about it. So the API request is, again, familiar to you all. It's very different based on what company you work at, what do you want to do with it, and how they establish that. But some simple examples are, well, first of all, everything includes an endpoint, method, parameters, headers, and body. Again, not to bore you with terminology, either you know this or it's not interesting, but just to know the overall feeling of this is a very familiar URL, right? This is medium.com, just articles. This is from your website, from your web browser. Like if you want to open medium.com, I don't know if it's the exact URL. I just, imagined it to be something like that. But you want to read articles on Medium, which is like, the blog post for tech community. And then you want to get articles. And then we all know this syntax, which is, the long URL in your browser with lots of weird symbols, which is the query, right? This is what you ask in particular. So if you Google something, the query will be, how many cats can I have for life and not be considered weird or something like that. This would be your query, right? So here we said topic is tech, which means that we're searching for tech because query equals search, and we're searching articles, right? So we're returning articles that are filtered by topic being tech. Easy, right? This is your normal web request. But here's the method get that we don't usually see because it's automatically considered by the web browser, which means that we are pulling something from the backend. So here, just to refresh off of this, right? HTTPS is our schema, classic. S means that it's a secure connection, as it should be in 2024. Medium.com is /articles is the endpoint, so that's the web server, which is Medium is a web server because it hosts web pages, right? That's how we get them. Because again, don't forget, this whole thing is just to return a web page, right? That's the kind of data we're getting here. Because you enter this in the browser, you get some visual stuff. You get the Medium web page with a list of posts there. Who makes that? Well, it's front end plus back end data that gets, again, from this URL that calls it. So if we have articles and then we have topic, this is the parameter, right? The parameter means that we're filtering out. So endpoint is medium.com/articles. Method is here get, so we're getting something. Parameters are the path variables that are topic equals tech. And the headers are not shown here, but you can see them here, for example. So they vary very visual, a lot of them. We can look at that later. For for example, it can be some other information about the user that might be interesting to the backend. For example, what authentication they're using, what is the user agent, so what browser you're calling it from. Stuff like that might be interesting to the server, and it might alter the response based on what is in this. And then the request body here is a different method, right? Here we don't need it because it's a GET. So we get everything we need just from this URL, right? We can fetch it. But if you want to post something, we need a little bit more data. And now, even though you could have put all of these parameters, because here we're posting, right? We're posting a new article to Medium. So here you would say title, my first post, author, Sparky, date, current date. You can put it all here, right? No problem. It does get a little messy though if you have like thousands of lines of JSON code that you want passed. So we use the request body, which is again a part of the request, to pass all of that. It might be JSON, it might be bytes of data, it might be an image that you're passing, whatever it is, right? For example, when you upload an image to Google search, it's not a JSON, it's you actually upload the image and they get the bytes and they analyze it. So I would say request body is good for, first of all, post, because post is when we send a lot of data, right? Get is request, and we get requests based on many parameters. They would all fit in here, even if there's like 10 or 20 of them. But here, this might be a 1,000-line file, something that is like, huge post, like all of the post is here. You wouldn't like typing it in there. So that's where we use the request body, which is usually JSON. So this is our endpoint, this is our method, this is our request body. We send it, we get some confirmation from the server, right? So the response that we get based on this is what the server sends us to know. Again, I know that this is mostly basic knowledge for you and common knowledge, but I just want to go through this so we're all on the same page here for the next stuff that we're doing. The backend sends you the status code, the response line, and response headers. That's how it usually is with REST APIs, right? So status code is our 3-digit code, which indicates the request went through. So if it's 200, it's good. If it's 204, it's good that something is not so good. If it's 404, we all know that, not found. If it's 500, then your server is dead, call the management, it's bad. If we get 200, means the post is good, it was published, we can assume. Here in the response body, we can get some other additional stuff from the server, like message, post published, date, when it was published. It's the code here, sorry. And the response headers are usually, again, for your server, just for your client to just know what's in the server, what are some parameters. So like here we have unpacked application JSON. This is a JSON file. Was not because we're going to assume this is a public API, just in case, because here is what we've missed here. So this whole thing, right, what I just explained is technically API documentation. So I explained to you how to make a call to a server with some data and get something back. So this is the API docs. Why are they important? Because that's how developers know what to send and what to get, right? And there are some great examples, there are some not so great examples. I gathered a couple here to just quickly go through with you. For example, there's a tool called Swagger that uses the OpenAPI schema to easily generate the docs for APIs based on your code. So this is pretty much all auto-generated by a special generator. And here we have a open API thing for pet store. So this is a pet store, we can call this. And for example, we have everything about pets, right? So put is used usually when you, again, by the way, all of this stuff like get, put, delete, it's not essentially required for you to use. Like you can call it whatever, you can call it post method. I've seen backends where post method gets something or get method post something. It's like, it's fine. It's just, you define it for the users to know what the action does. Because why? You see that here we have a pet that updates the pet and the pet that adds new pet to the store, which are two different things, right? Because when you update a pet that is already there. When you post, it's a new pet. And it's called the same thing, right? It's still /pet, which is the endpoint. So we use those HTTPS types to define what exactly you're doing. So for example, post user is add new user, put user or is modify the user, get user is obviously get the user, and delete is delete the user. And here you have one route, but so many types of requests that you can process. And it's just, to keep it simple because again, with APIs, we want to keep it simple. We want developers to know how to use it and we want us, when we go through this now, to easily understand what they mean. Because here, this is pretty obvious, right? Update an existing pet. Let's try getting a pet. So whereas the find pet by ID, for example, here, right? We have the parameter pet ID. We can set it here. It's an integer, right? They explain that this is the ID of the pet in the database or somewhere, I guess. And here is the application XML. This is a different type, right? We're going to use JSON here. So they return us the ID, name, doggy, category, photo URLs, an array of some URLs to Google Cloud or whatever they store photos of the dog, and some tags and some status, right? So basically we get the information. As you can see, the code is 200. If it's 400, then we messed up the request. If it's 404, then again, pet not found. All of these codes, by the way, again, most of them are standard, but you can use them as you wish. Like 404 can be, I don't recommend that, but 404 can be anything you want. 200 can be anything you want. You just send the code with the file, and it is acknowledged usually that if it's 404, it's not found. Again, just for developers to easily communicate with each other. Let's take a look at another very interesting API. This is one of my favorites, actually, and this is something that you can use in your projects. Spotify has great API for developers. The good thing about this is if you pay for Spotify, you can use this for free. So you just log in with your Spotify account and everything from here, so albums, artists, audiobooks, categories, chapters, like everything, you can pull and modify and get, running on this bottle, for example, anything with just your Spotify account, which is, I think, really good. And it's something to consider to use in your projects if I'll be building one for portfolio. I would strongly recommend finding something interesting but basic, for example, music API or, sorry? There definitely is. Everything has a limit. We can check it. Let's see if they say it anywhere. Uh, they changed the website, so we can check it out. There probably is definitely a request limit, and you probably have to request more. But I've used it for a mobile application where so the good thing about this, let's read API calls here. So the good thing about this is if you're using this API with Spotify, you usually use it on the user front end, right? So when you publish the application, you ask users to log in with their accounts. And since they're paying for Spotify Premium, it's technically all on them. So if you download the app that you developed for Spotify to call, I don't know, get the playlist. For example, a good example is, Spotify mobile app, it doesn't show what your friends are currently listening to. That feature on the web where you can see what the like last 15 minutes people listen to for your friends on Spotify. It doesn't have that. They removed that feature for some reason. I made a small app that was a widget for iOS that showed you that just with this API. Because again, once you download that app, you register with your Spotify account. And technically, if you reach there any limits, they're still going to be less than if you publish it on, for everybody. So I would say Spotify API is interesting because of this authentication style, right? Because you put the load on requests and everything else on the user, on a particular user, which is great. So you just, you make them register, they log in on the app with the Spotify form. We can, by the way, check it out here. So let's get an album or something. Yeah, very good docs. Really clean, like huge responses, everything you need. And like try it. For example, you see where it's gonna go? It's gonna go here. Now it doesn't tell me that it's like a Spotify developer account. It's just, Spotify account. So I'll have to log in and it's gonna be like, oh, okay, this user who's paying for Spotify Premium is trying to call this API. Fine, okay. I not sure, not sure, but I would expect it to. I don't know if they put ads in the responses, which you might expect. Haven't tested. Good question, but if you want to explore that, absolutely. I would say that with premium works really well. Doesn't get any limits or anything like that. So it's really nice because again, they secure everything for you, right? It's authentication 2.0. It's really good. So it's all on them. You just have to get the key and call whatever you want. And by the way, speaking of calling, so we have the album here, right? So how do we get it, right? We know that Spotify has this IDs. So you know those little tattoos that people make with those Spotify IDs, the QR codes. You can make that. You can literally make an app that scans them because they have some scanner thing here too. I remember because they have a lot of stuff. They even offer you a part of their app where they get the predictions from. So they show you the analytics part that shows the style of the track, the genre, the mood on based on which they determine what to play next, right? That's Spotify magic when it knows what you're in the mood for next. They actually expose that to you. So if you want to use that in any way, you can do that too. The good thing about this, again, we live in 2024, so you can always use this with MLs. So if you want to pipeline this with LangChain or something else, to, I don't know, present something to the user based on this data, what they listen to, what, the albums are trending right now, something like that, right? It's up to you again, because you come up with something, just some idea, something simple, some summarization of, I don't know, a top chart, how many places Taylor Swift is keeping in the top charts this month or something like that. Something simple. Again, it's your project already. You made it. Did you have to code the whole backend for it? No, no. You just made a simple API request, even on the front end. But it's your project, and you can put it in your portfolio, and it's better than not having anything, right? And also very, very low effort. So this is a good thing to consider. Let's take a look at this also first, NASA Mars API. Very interesting API. Again, if you want to use something impressive on your resume, this is a good one. It's kind of fun. I wouldn't say it's like super useful. All of these links, by the way, you can find